All right, let's dive into something I think is pretty incredible. The idea of running your very own team of AI agents. Yeah, a personal AI swarm, right on your home computer. Let's get into it.
I mean, just stop and think about that for a second. We're not talking about just one AI, we're talking about a whole coordinated team of specialists, all working together in parallel to solve really complex problems for you. And the best part? It's all happening locally, on your machine. That means you get total privacy, no monthly fees, and it even works offline. It sounds like something out of a sci-fi movie, but believe me, it's quickly becoming our reality.
So, to really understand how this all works, we're going to climb what I like to call the hardware ladder. We'll start with a PC that a lot of you might already have, and we'll go tier by tier, seeing exactly how more power unlocks more of this amazing multi-agent capability.
Okay, so our first rung on the ladder is a really popular piece of kit, the NVIDIA RTX 3080. It's a fantastic card for gaming for sure, but when it comes to running an AI swarm, it has one major limitation. And that limitation, well, it all comes down to memory. For AI agents, VRAM is everything. This chart really breaks down why. That 10 gigabytes of VRAM gets eaten up fast. The AI model itself, even a relatively small one, is going to take up about 5.5 gigs. Then you've got the context window, which you can think of as the AI short-term memory. That's another 1.5 gigs. And just like that, you're left with a tiny 3 GB buffer.
So, what does that math really mean for us? It means you hit a hard limit. With an RTX 3080, you can run exactly one active AI agent at a time. If you try to run more, you'll crash. It's a starting point for sure, but it's not exactly a swarm, is it?
Okay, so let's climb up to the next rung and see what happens. Meet the RTX 3090. Now, its key advantage isn't just a bit more raw power. It is a massive jump in video memory. We're going from 10 gigabytes all the way up to 24.
And this visual just perfectly illustrates the difference that makes. With 24 gigs, we can load a much smarter 20 billion parameter model, which takes up 13 gigs. But here's the real game changer. Look at the context. We now have enough memory for 2 separate agents' context to exist at the same time, and we still have that safe 3 gig buffer.
And the result? Boom. You've just doubled your capacity. You can now run 2 AI agents at the exact same time. Your one-person team just became a powerful duo. This is where we start to see a real swarm emerge.
So let's just put them side by side for a second. The jump from 10 gigs to 24 gigs of VRAM directly translates to a jump from 1 agent to 2 agents running in parallel. This is the fundamental rule here, you guys. Memory is concurrency.
All right, let's switch gears a bit and climb to our third tier, the new M4 MacBook Pro. Now, the magic here isn't actually a graphics card, it's Apple's unified memory architecture, which gives us this huge 48 gigabyte pool of memory to play with.
And with 48 gigs, things get really interesting. We can load a seriously powerful 32 billion parameter model, taking up 20 gigs. But just look at that context space. We now have 16 gigs available, which is enough to run 4 separate agent contexts simultaneously. And we still have plenty of breathing room.
That's right, 4. We've just doubled our swarm size again. 4 simultaneous agents all working in parallel. We've basically gone from a single coder to a small, highly efficient software development team, and it's all running on a laptop. And the ladder just keeps on going up. Tier 4, a Mac Mini with 64 gigs of memory can handle 6 agents at once. And at the very top, you get into enterprise-grade machines like the ASUS Ascent with 128 gigs of unified memory that can run a swarm of up to 12 agents. It's just incredible.
But hang on. What if I told you that just throwing more raw hardware at the problem is only half the story? Yeah, the real secret to making these swarms not just big, but truly effective lies in some really clever software.
A key idea here is something called lazy loading. Think of it like this. Instead of handing an agent a giant 1,000-page instruction manual for every possible task it might ever do, you only give it the one specific page it needs, right at the moment it needs it. This technique saves a massive amount of precious memory in that context window.
So how do you actually set this up? It's basically a 3-step process. First, you set a global configuration file. Second, you use dynamic rules that are smart enough to inject information only when it's needed. And third, you define these custom lazy loaded skills for all your specialized agents. Okay,
So we have the hardware for parallel processing, and we have the smart software for efficiency. So what happens when we put it all together? Well, we can give our swarm a really complex multi-step task, something the developers are calling ultrawork, and just watch as it coordinates the entire solution.
Just look at this prompt. This isn't just asking an AI to do one simple thing. No way. This reads like a directive from a project manager. It says, hey, refactor this code, but then it specifically delegates subtasks to specialized agents, the @hardware architect, the @QA enforcer, and the @root cause debugger.
And here's the magic. The client software is smart enough to automatically deconstruct that one single prompt. It spins up the hardware architect to optimize the code. It gets the QA enforcer to write the tests, and it unleashes the debugger to hunt for a bug. And because of the hardware we chose, it runs them all at the same time, in parallel.
So when you combine the right hardware with this kind of smart software, what you're really creating is your own personal AI supercomputer. It's scalable, it's local, and it is unbelievably powerful.
Look, if you remember just one thing from all this, let it be this right here. The power of your personal AI swarm is a ladder, and the rungs of that ladder are made of memory. More gigs of RAM or VRAM directly, and I mean directly, translates to more agents working for you in parallel. It's that simple.
You know, this technology is moving at an absolutely breakneck pace. What requires a high-end server today is probably going to run on a standard laptop tomorrow. So the final question isn't about the technology. It's about you. When this power is in your hands, what will you build with it? What kind of problems will you solve with your own personal AI swarm?